This question is from strength of materials for 2 marks. At a critical point in a component, the state of stress is given as sigma xx is equal to 100 megapascals, sigma yy is equal to 220 megapascals, sigma xy is equal to sigma yx is equal to 80 megapascals, and all other stress components are 0. The yield strength of the material is 468 megapascal. The factor of safety on the basis of maximum shear stress theory is. We need to round off the solution to one decimal place, and the accepted answer range for this numerical answer type question is 1.7 to 1.9. Let's proceed to the solution. We are given with sigma xx is equal to 100 megapascal, sigma yy is equal to 220 megapascal, and sigma xy or tau xy is equal to 80 megapascal. Since we are given with a biaxial state of stress system, the first step is to calculate the principal stresses using the formula sigma 1, 2 is equal to sigma xx plus sigma yy by 2 plus or minus under root sigma xx minus sigma yy by 2 whole square plus sigma xy square. So substituting all the values and simplifying will give us the principal stresses as sigma 1 is equal to 257 megapascal and sigma 2 is equal to 63 megapascal. Since we are asked to calculate the factor of safety according to maximum shear stress theory, the first step is to calculate the maximum shear stress using these two principal stresses, and it is calculated as tau max is equal to absolute value of sigma 1 minus sigma 2 by 2. So substituting sigma 1 is equal to 257 megapascals and sigma 2 is equal to 63 megapascals, and simplifying this expression will give us the maximum shear stress as 128.5 megapascal. Therefore, according to maximum shear stress theory, we can write tau max is equal to yield strength divided by 2 times of factor of safety. From that, we get the factor of safety by substituting sigma y is equal to 468 megapascal and tau max is equal to 128.5 megapascal. So simplifying that will give us the factor of safety to be 1.8.